coming tonight, parents. The purpose of tonight is to give you an introduction to DNC, Developing Number Concepts. So really we're giving you a DNC 101. What is it? So our goal for tonight is for you to walk away with a better understanding of what's taking place during your child's math time. I want to take a few moments and point out our parking lot. I've got on our word wall over here. You have sticky notes on your table, so if at any time you have questions, anything that piques your interest, you're wondering about, feel free to jot it down and attach it to our parking lot. And at the end of the evening, I will check that and see if I can answer those questions at that time. You might find that some of our questions have been answered through the evening, but feel free whenever you have a question to jot it down and stick it up there, and at the end of the evening I'll hopefully have addressed those concerns or questions, and if not, that will be my time that I'll get to those. So without any further ado, DNC, Developing Number Concepts 101. What is DNC? We're going to begin this evening by watching a video clip of Troy. And you're going to see that Troy is a first grader, and we're going to watch him solve a problem first as a first grader. And I'm going to show you actually 3 video clips. The first one is just to give you a glimpse of what is going on in the classroom. This is actually, we're going to give you kind of a layout of what the math workshop looks like during our day. And so this is the number talk and math talk portion of our lesson. So I'm showing you just this first clip so that when I show you the first video of Troy, you know what other students are doing, what the teacher's purpose is, what's going on in the classroom. So I'm going to go ahead and show you that video of Troy.
Patty has asked a group of first and second graders to gather on the rug for what we are calling a number talk.
Watch what I write on the board. Did you build that fast part? I'm going to write a number here. If you can do it in your head, try thinking about it first. If you need to use the cubes, go ahead and solve the problem any way that you know how.
Okay, so again, the purpose of that video was just to give you some background so that when you see the video of Troy, you can see what it is that he's doing, why he is solving this problem. So you can see the purpose of this time is the students are all gathered on the carpet. The teacher has posed a question, a problem, to solicit some higher level thinking from her students. So now we'll watch Troy as he solves this problem, 28 plus 14.
I had 28 and I counted 14 more.
How'd you do that?
I counted on my fingers.
All right, so you counted on from the 50.
And I had 42.
You got to 42. Okay, thank you.
All right, so you can see he counted on with his fingers, which is not the best response that we want from our first grade mathematicians. So now we're going to watch Troy a year later with some more expertise, some more time with developing number concepts, and you're going to see he has much more refined techniques.
Oh my gosh.
Myra, just hang on for just a second. I want to give people some thinking time. Thumbs up if you think you have the answer. Troy.
30 plus 24 equals 54, plus 6 would be is 60, plus 1 more equals 61.
And where'd you get the 6?
I broke the 7 into 6 and 1.
All right, thank you.
All right. So, as you can see, that's pretty high-level thinking for a second grader now who's had some time in our Developing Number Concepts program to be able to look at numbers and break them apart the way that he did, to see groups of 10s And to break the ones apart, he broke the 7 into a group of 6 and 1 to make it easier for him to add. He didn't use the rote algorithm like we were taught growing up to use. Again, wasn't using fingers like he had initially. He's gotten some more refined techniques and strategies to use as a mathematician. So what is the philosophy behind DNC? It's got 4 basic principles that we're really relying on, that we're instilling in our students. And that the first one is that children develop an understanding of concepts through experiences with real things rather than symbols. And this means that children need hands-on experiences with math concepts for them to be concrete rather than our traditional paper and pencil tasks that we grew up doing. The more hands-on experiences they have, the more concrete that learning has become. So children also need to be engaged and on the edge of their learning, so that when they are self-directed in their learning and pursue challenging tasks until they've cemented that learning, then they're then ready to move on to the next task. Which kind of brings us to our next philosophy, that students are in control of their learning. They choose the stations that they go to, they choose the location in the room that they work in, they choose the manipulatives that they choose to work with, and they choose the students that they choose to work with. So they're in a lot of control of their environment and in a lot of control of their learning. So they're choosing the tasks that are challenging to them, and they continue to work with those until those tasks are no longer challenging, and they're ready to move on and tackle the next challenging task. And the last philosophy point we have is that practice makes perfect. And by no means are we saying that we expect our mathematicians to be perfect, but the old adage does prove true, that the more practice you have in something, the more experience you have, the better you are at it. So what does math look like in first grade? This is the structure of our day. And so I'm going to walk you through how this is structured in our first grade day. We begin with a number talk and math talk, which we saw in that video with Troy. So what happens is we spend about 5 or 10 minutes in which we engage students in looking at numbers, finding parts, telling time are one of our many math objectives. And we might look at using number cards, dot cards, toothpick cards, as the kids we're very familiar with. And we look at different parts, how they see numbers and parts within those numbers. We also look at time and some of our other mini math objectives. So this is how we're really getting them to think critically. But then the other element of it really is sharing that thinking. We simply don't accept a right answer. We want to know how they came to that answer. So sharing your thinking is really the most important step to us. Can you communicate that thinking to us? So as you saw in that video, students have a procedure that we carry from K all the way to 5 in our number talks and math talks. When you know the answer, put your thumbs on your chest. And then once we see that our students have all had time to think, they then raise their hand if they feel comfortable enough to share. So that's the structure that we've got in place in our school from K through 5 that was really developed by Kathy Richardson in her DNC program. We then move into a whole group hands-on lesson, and the purpose of this is really we're getting time to spend introducing stations, whole group, so that directions can be taught and are very clear and explicit. This is our time where we can focus on questioning and laying the groundwork for the kind of thinking that we expect to see while students are out in these stations. We usually will lay out a station, introduce it to the class a couple of days, maybe a week before it goes out into stations. And this gives us time to really make sure that our students are comfortable with and understand the tasks that we're about to send them off to do. We help model the kinds of questions that we should see them asking each other, asking of themselves as mathematicians, so that we're seeing that higher level thinking as they go off in their work. Then the next part is really their most enjoyable time of the math workshop model, and that is their independent practice. They know it is station time. So once we've done our whole group lesson, I send them off, and this is when they have choice. They come and select the station that they're going to use, the manipulative they're going to use, the location in the room that they want to work, and then the people that they want to work with. So this is by far the most enjoyable time for them, but this is when we come around as teachers and start questioning them. Tell me about what you noticed. Tell me about what you're doing. And we really find out what can they do as mathematicians, and we help push their thinking just a little bit further, find their edge as mathematicians. And last, to wrap up our lesson, we have share time. So we'll pull all of our students back to the carpet and talk about what neat things they discovered as mathematicians that day, any new ahas that they had, something new that they discovered, something really cool that their friend did. That's how we kind of bring our math workshop to a close. So I know you probably are wondering, how can you help at home? So we've got some really great ideas for you. We have a monthly optional homework journal that goes home every month. Most of our teachers have that going home. So that has a math section full of great ideas that always are in line with what we're doing currently in our classroom. Really, like I reiterated earlier, the process is more important than the correct answer. And it's so important that they're able to communicate how they got to that answer. The why, the how is so much more important than what it is that I got for an answer. So if you can ask your child at home, well, how did you get that? Tell me what you were thinking about. That's what we're doing here in class to find out. I have no way into their head. And so by getting them to talk about it, that's how I can find out what they're able to do, what their skill set is, and what I need to teach next. Throw away the flashcards. No more drill and kill with those flashcards. Instead, we want to create meaningful experiences for your child to count, sort, compare, pattern, join and separate. We've used those words a lot to make sure that our students understand that joining is adding, that separate means subtract. But we want them to have fluidity with that vocabulary. So join and separate objects of your choice. I've given you some great ideas. You don't have to go to Lakeshore and spend money on manipulatives. It can be the simplest of things that you have at home with different food items like Cheerios and Skittles, beans, but then random objects you have around the house like keys and shoes, counting shoes by twos. You hopefully have pairs, and counting those by twos is great, the number of feet in your house. Those are excellent opportunities that really lend themselves for counting. Toys, I know you have them all over the floors, so count those as you're putting them away. We're really finding that a lot of kids, unfortunately, are coming not able to count quite to the level that they need to be able to. Our first graders need to be able to count all the way to 100 by the end of the year. They're supposed to come in to first grade at 32, so we go from 32 all the way to 100, which might not sound like a big road, but that's kind of a big road to travel, to be able to understand how numbers work and put them in order. So I wanted to spend the rest of our time showing you what it is that our students are doing right now in stations, so you can actually see for yourself what stations look like. So I have picked 3 stations to show you. This first one is called plus and minus trains. And so you'll see that the kids have a long train of 20 cubes. And so they work, this is a partner activity, but it can also be completed completely independently. Most of our activities really are independent activities, but they like the bonus of working with a friend nearby. So the first thing we talked to them, laid out when we got this station out, was the importance of talking, communicating to my partner what it is that I'm doing. So I have an action dice, and our action dice is really our plus and our minus. That's telling me what my action is, whether I'm joining or I'm separating. So I roll that first, and you can see that I've rolled a minus. Can I subtract? Parents, can I subtract? Yes, I can take away, and I can take away 2. So I would tell my partner any variations, because as mathematicians, our skills range. So I could simply tell my partner, I rolled a minus 2, I'm going to take 2 away. If I'm more skilled in my math, I might be able to write and record in my math journal minus 2. I might even be able to tell my partner, I had 20, I got a minus 2, I had to take 2 away. I might be able to then be able to say, I have 18 left. It depends on our level, but you can see that our stations really lend themselves to differentiate for our varying levels of mathematics needs that we have. So I would continue going my partner, it would then be my partner's turn. But if I'm working independently, I'm going to go ahead and roll again. Oh, this time I got a plus. Let's see what I roll. And I got a 5. The first thing we want our students to be able to realize is, I don't have 5 to add. I can't add 5. I only have 2. I can't join 5 more. I lose my turn. So they're really learning the value of, I can't take away when I don't have anything to take away. I can't add when I don't have enough to add. So that there's a lot of value in that. They're also learning the value of the action itself, joining and separating, adding and subtracting. So that is plus and minus chains. The next one I wanted to show you is called Change the Number. And in this station, I'm going to turn it this way, it consists of a board with 10 dots on it, and I have a number cube. Very, very simple activity. You'll find that the activities that we do are very simple. We keep them very simple. That way it gives the children time to really focus on the math that they're doing. If you keep the task simple, they can think. If the task is too hard, they can't focus on the task and the thinking at the same time. They can do one or the other. So our tasks are very, very simple, allowing for that thinking to really come to the forefront. So my job now is to roll my number cube, and I have a 2. So right now, I know as a mathematician I have 0, I have nothing on my board, and I need to change that. The station is called Change the Number. So I need to change my number 0 into a 2. So I know as a mathematician I need to add 2. So I'm going to get a manipulative of my choice. And for this activity, I'll use color tiles. And I will add 2 to my board. All right. Now I can simply tell my friend, I rolled a 2, I had to add 2 to my board. I could record a plus 2 if I'm ready to record. I could record a 0 plus 2 equals 2. You can see the range that this allows for depending on the child's needs. So now I'm going to roll again. And this time, upside down, I rolled a 5. So I have to change my number from a 2 into a 5. So I have to know that I have 2 already. To get 5, I'm going to need to join or I'm going to need to separate. That's the first step I have to figure out. Then I have to figure out how many more I need to add. And last but not least, I wanted to show you this evening counting boards, reading equations. And our counting boards are just storyboards. They come, oh dear, in different arrangements. We have houses, barns, streets, skies, trees. The sky's the limit on them, but the purpose of them is for the kids to use them to create story problems. So the kids have a bag full of addition and subtraction problems that they will pull out. And the object of this one is to show fluency in reading the problem, to be able to read it, and then be able to create it as well, to create a problem that matches it. So I know I got the problem. I have to be able to read this in order to build it. I drew 0 plus 3 equals. So I need to build that on my storyboard, and I get to use my imagination on storyboards. And I might say there were 0 children in the house, but Mom called them for dinner, and all 3 children ran into the house. Now there are 3 children in the house. So the kids have a lot of fun being able to invent their own stories, but I can see the math in this is they've got to be able to read those equations, build it, and then now I'm ready. I can write that equation down. I can write my answer to it as well. I'm going to leave this one out so that my teacher can circulate. When she circulates around, she can see all of the storyboards that I've created. So I would push this one off to the side, take out another one, pull out another equation, and start my next work. For this one, I got an addition problem. I got 2 plus 4 equals. So this time, there were 2 apples on the table, and then Mom got 4 more out of the refrigerator. Now there were 6 apples on the table. Once I finish with this board, I'll push it off to the side. That way, when my teacher circulates around, she can see all of the work that I've created, and I start on my next storyboard. So I thought I would leave these out for you guys to see if you want. I'm going to put these out if you'd like to try them as a first grader, see what it's like to do this work. If you have any questions, feel free to write it on a sticky note and put them on the parking lot. That way I can answer those, and I'm going to get to those questions probably in about 5 minutes. I'll let you play as a first grader, and then I will get to those questions.